Welcome back to my channel. I'll be doing this generate parentheses today and also the crossword formation, not all in one video. And I was not able to make a video of this too. Anyway, I can share a little bit detail on this part where I did uh, basically this one was we are given a list node and we had to add a value in between. So this is already submitted and this is my solution, which is the shortest one in Java. The character count is 163. um, so here what we did is let's say we have these 4 nodes and a new value 5 is to be inserted, then we have to insert it in between 4 and 5. One thing to note here is I didn't write all this code at my first attempt. It was based on repetitive iterations. That's how any code will be, right? So the basic idea of the very smallest data structure should be known, and after that it's all iteration and practice and all those kind of thing. So here what we did here is to insert any value in a list. What we need to do is we need to actually first find out where it is supposed to go, right? So at first what I'm doing here is I said, okay, this one is the previous node, whatever is coming till here. If we want to insert 5, then if 4 is our previous node and if the next node is 6, then we want to, that is which 6 is greater than 5, so we want to insert it in between 4 and 6. So that's how what we did here in this loop is at first we said, okay, the first is f, the previous node will be null, but at this point what we did is we created this new node which is to be inserted as a list node, a complete node of 5, and then we even set it as b just for code golfing purpose, else it would be null, just for a basic understanding. So what we did here is, okay, the basic idea was to move the forward pointer forward and forward. So once we go one forward, then the next time this will be a previous node. So that's how we went. And if the value in this is smaller than v, that is 1 3 is smaller than 5, then we keep on going forward. Now when the f reaches this point 6, we say that, okay, that's the end of our iteration. So our next f will be 6 and our previous node will be 4. So what we did is previous dot next will be 5, and this 5 dot next will be 6. That's how this was created here, right? So that's it. And why I did p equals to n is equals to n is, let's say if this node was 0, then at that point what would happen is our next node will be, our f will be 1, which is smaller. So the first node, there is no p, so that's why we just said, okay, this 0 dot next would be 1. Just a high level. If you want more detail, I can of course write it down, but that's it. Let's solve this generate parentheses today. So what it says is, okay, you are a coder, you know how important it is to have a closing parenthesis for every opening parenthesis. Okay, given n pairs of parentheses, write a function that generates all the possible combinations of regularization sorted in lexicographical order. So lexicographical order means basically ascending order, right, of all these values. So what we'll do here is, let's create a set as is equals to new hash set, which will record all our individual and distinct parentheses. So if we have the size of n, then we have 4 openings and 4 closing brackets. That's why so if the total length is 8, then we can say, okay, that's a valid parenthesis if we can make a valid parenthesis. So let's just say, okay, return s dot to array. So whatever is populated in that set will be our final. Or we can basically do this as a tree set with some ordering and lexicographical ordering. Now what we can do is, okay, we'll run through a backtrack method. Let's call it B. We call it backtracking because this is weird, sometimes my keyboard doesn't work. So we do a backtracking because whenever we create a first node, we do not know when it ends, so we keep on tracking it and then form all these valid strings. So just to look at it, this is a well-known problem actually, based on backtrack also. So let's say we have the value of n, we need to create a valid string of n and populate everything in s, and every time we do that we need a opening bracket and a closing bracket whose numbers will be equal, right? So at first our opening bracket is 0, and next we have a closing bracket is 0. Let's do with this opening bracket, and then we can also pass in the current string. So to form the string that needs to be added to a set, s is basically whatever will be formed here. So let's look at how we'll do this. So we are not returning anything, let's just call it b void, and then what we'll do here is we have a size of n, the length of strings will be this, the set is s. Let me type on my own keyboard, it doesn't work, I have a problem with my keyboard. Set s, and then int opening bracket is o, int closing bracket is c, and int current string. Okay, let's call this set a map. Let's what happened here is, okay, let's call it object because we are not giving any type to the set. This one is not this is a current string, so string c will be no current string, let's call it s. Right. Now what we know is if opening bracket is equals to n and closing bracket is equals to n, then we know that's a valid string. So at that point what we say is okay, this in map add this as current string, right? And also what we'll do is, now if there are 8 characters already, then we know that's a valid string. Now what we want to do is we want to open first and then close it. That's how we want to backtrack. So to do that, let's see, if our opening bracket is less than n, right, less than n, then what we do is we do a backtrack again similarly, and then what we do is set our opening bracket will be opening plus 1, closing bracket remains closing, and then whatever our current string is, in that we will open it 1, right? And once we have n, we can open multiple openings, but it should be less than n, and then we have to close it, right? Openings and closings. So let's say if till when the closing bracket is smaller than o. So if the closing bracket is less than opening bracket, let's say we have 3 openings, we can't have 4 closings. That's why the closing brackets will always be less than o. At that point less than or equals to, closing is less than or equals to, right, till that point. Now what we'll do here is so this is the closing. In a current string we'll just close. So why is this an error? String and set is m, not metal, set is m. So if we run this sample test, let's see what it generates. Okay, time limit exceeded. Why is the time limit exceeded? Because if O reaches, oh, not this O n, but C is 1, Okay. Oh, there are too many. Does the closing has to be less than openings? One, two, three, four, and then while yeah, because at that point, at the third, it will add one more and it will be four. So that makes sense. So yeah, I think that's it. We have 197 characters. So we are somewhere here. How do we golf it? So what we can do is, if opening plus closing is 2 times n, will it work? No, it doesn't. It created a lot. Can do this maybe. Yeah, we don't need to go till n also because one will be added and then it will just return. So this should be fine. And can we say O plus C equals to 2 times n now? Oh, yeah. So this is one, not a major improvement, just 3 characters. Well, basically this is how you do a backtracking. I hope you have a basic idea. I didn't want to do much of a code golfing right now. It's very late in the evening. It's 10:31. But that's the basic idea. Thanks for watching my videos again, guys. Uh, have a good night. Bye.